going to go over some of the resources and things that and some of the fun things you can do with students in 3D printing. And this will be a little similar to the workshop I gave a few years ago on 3D printing, but I've taken it a little further since then. So for the agenda, we're going to talk a little bit about 3D printing. I want to go over the evolution of a project that I've been working on since I came to Sequoia, and show you how it's changed because of 3D printing. We're going to talk a little bit about pedagogy. I'm going to share some resources. And because so many of our kids are at home now, I want to share with you some ideas on how to extend this into to those students who can't come to campus. Okay, so I'll give you some ideas on how you can bring not just 3D printing, but 3D resources and more interactive resources to use with students. And then I'll give you a chance to design your own and do some sharing. All right, here's a 3D printer. So what's a 3D printer? Besides these things that are running up here, what do you know about 3D printers? What are your ideas? What? It builds in layers, okay. Okay, so there's some kind of program that controls it. These really aren't that complicated. It's basically a robot and a hot glue gun. So once you learn how to control the robot will control where the hot glue gun goes, and it builds things with it. It's called additive manufacturing. So it just adds layers on after layers. So you can create something with a 3D printer, or you can reproduce something. So, Christy, I know you know what this is, so don't tell anybody. What is this? And I'm listening to Lehigh, so if you want to come in, and if you're online and you want to talk, ask questions, feel free to unmute. Anybody want to guess what this is? It looks like a pyramid, okay. A little older. Anybody want to guess how big it is? You show me with your hands how big you think it is. Okay. All right. This is a 3,000-year-old Mesopotamian clay tablet. Okay. And this is one of the most famous clay tablets. It even has a name. It's called YBC 7289. And you can Google it and you can find out all kinds of cool things about YBC 7289, but don't do it now because I don't want to give away any secrets. But this is part of an evolution of a project. So when I started teaching here, I had to teach history, and it was really the first time I'd ever taught history, but I've always been a fan of teaching history, and I'm going, okay, I get to teach about Mesopotamia. I don't know anything about Mesopotamia, so let's see what I can find out. And they do this cool stuff called cuneiform writing in Mesopotamia. And I said, well, I want to turn it into a project. And I found a place online, a tool online that lets you convert English words into cuneiform. It's fake cuneiform because it's really an English word written with the symbols assigned to each English letter. So I said, okay, I can make this a project. And this is actually not from the first year I did, it's the second year. I can tell that because I asked the students to design 3D printed tools, 3D printed stylus to make their cuneiform. I didn't tell them how to do it, so each student came up with their own tool. And because, what's the main shape you see in cuneiform? Triangles, okay? And so most of the tools had triangular shapes. When I was doing a little bit of reading about cuneiform and how they wrote it, the reeds in that area have a triangular stem shape. So that's why cuneiform looks like a triangle. It's because they used reeds to write it. So what the students did is they wrote a story as though they were in ancient Mesopotamia, and then they translated that into cuneiform. and made their own tablets. Sometimes the tablets, let me switch screens real quick. There. I just shared this screen. Yeah, so when I, you know how to share in Zoom, right?
Yeah.
Okay. So when we go back to the PowerPoint, it's gonna be a little bit. So the kids actually made these clay tablets, and they did a really good job, although these are English words written on a clay tablet. Some of them even made parchment. So they printed it out on a computer and aged it. I think they aged it with coffee. So that's what that looks like. And then this year I'm going, okay, I was reading an article about 3D printing and teaching, and it mentioned YBC 7289. And I'm going, well, I want to print that. That's this. It's not very big, is it? I'll put one under here. So I have two. I printed two. It took about, and I only printed the front side because the back side's kind of scrungy. It took about 2 hours to print this. Okay? But it's durable, it lasts a while, and it looks exactly like the picture. I know you can't see it too well in a document cam. Let me hit focus. Anyway, you can go back to the PowerPoint. Thanks, Stephanie. But this turns out, and I'll pass this around. Oh, this is the kids doing their Mesopotamia Museum. Some of you saw that last year. Okay. And using tools to make cuneiform, so showing other students how to make cuneiform. Doing some augmented reality, that was fun. All right, so here's this tablet. And what's really cool is this is a thumbprint. So it's got a 3,000-year-old thumbprint on it. And it turns out, go ahead and go to the next slide, that each of these things is a number. But that little eye-shaped symbol in the corner means 30. So each one of those little symbols means 10. This symbol here that looks like a golf tee means 1. And as it turns out, this is somebody's math homework from 3,000 years ago. And so the next phase of this activity would be to get students actually writing math using cuneiform. And this is real cuneiform. It's not some translated app that I found online. And they can do it. So that's 30 units long. They're using Pythagorean's theorem to figure out how long the sides are of the cross pieces. So yes, this is scratch paper, or this is somebody's homework that the dog didn't eat. Okay, go ahead, next. I'm going to share the article with you that talks about how to use this with math. But again, here's the article. It's from 2016. And you get YBC stands for the Yale Babylonian Collection. And they go next. And this is the math on how to do it. So I really like where this project can go. A lot of it has to do with 3D printing. I had no idea that these clay tablets were so small. But it makes sense that they would fit into somebody's hand. And it makes sense because they find thousands of these clay tablets. This same article talked about how they tend to be unfired clay, so they're very fragile. So one of the ways they conserve them is to actually fire them in a kiln. They complete the process and make them vitrified, solid as glass. Okay, next. So here's the two tablets next to each other. This is the real one. Here's the 3D printed one. You can see they're pretty close. It's pretty good. But before we printed it, I had no idea how big it was. You can see a scale on a picture, but the scale really doesn't mean anything. At least not to me, until I actually see it. And that's one of the cool things you can do with 3D printing. Okay. So pedagogy. Let's talk about some of the ways to use this in different classes and things. Go ahead and go to the next slide. I don't know if you've heard of the word haptic before. You have? What does it mean to you?
Well, when I observed in your class, I saw students working with people. They assess themselves and see what they understand on steel plastic cup.
Okay.
Before you cup. And then they just use the scale throughout the year.
Okay.
That's what I remember.
That's what you remember? Okay. I actually didn't learn about this term until a couple weeks ago. But haptic means using your hands, but in this case, it's also interacting with technology. So it's using your hands and interacting with technology. Where do most of our students, even when they're not in online classes, spend most of their time? Online or interacting with technology. They're playing with games on their phones. This is the world that our students are living in right now. Even when they're in school, they would rather be playing with their haptic technology. And so by producing learning experiences in the haptic environment, we're meeting our students where they already are. And I think that's kind of a cool concept. I'm not going to spend a lot of time talking about this, but go ahead and go to the next slide. So here's an example. And many of you have probably seen this cup before. Okay, looks like an old rusty cup, but it's 3D printed. This actually, I used a glow-in-the-dark filament, so it actually glows in the dark, which is kind of fun. And I painted it to look rusty, and it was from the museum that I did last year. But this actual cup, the actual artifact, was found in a Civil War site after the Battle of Fredericksburg called Camp Misery. And it's where the Union soldiers retreated after the Battle of Fredericksburg. And this was found in the corner of the tent site. Somebody just left it there, near a fire pit. And picture muddy, cold. It was January. There's people screaming and crying because they've been injured in battle. And somebody forgot their cup or lost their cup. But this would be, you could picture how it'd be used. But the actual artifact had decayed to the point that it probably doesn't even exist anymore. So the only thing we have of this artifact is this 3D printed relic. So here it is again. I usually print things in white because it makes them easier to print. But the other thing you can do, and sorry you can't see this online, is there are programs, and I'm giving you a link to one of the programs called Mesh Mixer, and it's free. That allows you to slice these things. And that's what I did with this thing. I sliced the back off with Mesh Mixer. If I left the back on, it would have been a 9-hour print for this Mesopotamian tablet. But by slicing the back off, it was a 3-hour print. But this cup, I hot glued a magnet to it, so then I put it on a whiteboard, and then I draw thinking maps around it. So I'll put it in the middle of the thinking map and have kids come up and brainstorm ideas. What do you know about this cup? What can you tell? What do we want to learn? With the cup at the center of that thinking map. Okay.
You want to put it here?
Yeah. I usually buy white filament, but the Dremel has blue filament in it now because it came with a coupon. And if you put an online review and then took a screenshot of the review and shared it with them, they'd send us 2 rolls of filament, and they happen to be blue. So this one has blue. But we can order other colors and stuff. Okay. All right. Since we've got the document camera going, I'm going to go ahead and leave it. You can leave it on, Stephanie. I can show off a few other things before we get back to the slides. So here's this cup for those of you online. And you can see that's half of the cup. And here's the full cup. So by cutting it and slicing it, I'm saving some of the printing time, some of the printing cost, but I can also do other things with it. Kids can also, if you cut the objects, students can mount them on their displays. So they're adding technology to their displays. So if they wanted to do it that way, they can. Here's another historical artifact. This is a mastodon tooth that was found in Benjamin Franklin's basement. So it was a mastodon tooth that belonged to Benjamin Franklin, and I sliced the bottom off, again, to save some time. Some of you have seen this before. This is a shackle and a key. It was once used to enslave somebody. It's a lot of history. Anybody want to guess what this is? zoom in.
Like a pipe?
It's a Roman oil lamp.
Oh.
Yeah, but this Roman oil lamp has a really cool history behind it. It's about 2,000 years old, but it was found in Jamestown, a 400-year-old, 500-year-old site in one of the first places people colonized. It belonged to somebody in Jamestown, and it's interpreted as being an item from a cabinet of curiosities. So a wealthy person owned this and had it in their personal museum. And they brought it all the way from, they valued this item enough to bring it back, bring it over here from England. And maybe they found it in Rome, who knows, but that's, and then a student painted it.
Color?
A student painted it for me.
Oh, okay, so
Yeah.
you can paint over it.
Yeah, so you can paint these and make them look really nice. So there's a lot of history you can do. Science, let's do some science. Anybody want to guess what this blob is? And I'm watching the chat, so if you're online and want to add to the chat. I'll show you in profile.
Oh,
It's upside down. This is Hawaii without water. Yeah, so it's Hawaii. These are the island chain of Hawaii. Imagine what Hawaii would look like without water. This volcano, the big island of Hawaii, is taller than Mount Everest, from the floor of the ocean to the top of the volcano. Yeah, and that's what Hawaii looks like without water. Oh, you want to see that? It's Cuba without water. I don't think Puerto Rico made it onto this map, but there's Cuba without water. So this is the Gulf of Mexico without water. Really, again, these take about an hour to print, but they're really durable. So you get years of use out of one print. And trying to buy, it costs pennies. I could probably print this model for maybe 40 cents, where if I was to buy it online, you're looking at $30, $40, maybe more.
So that material is inexpensive? So I don't know what it is.
No, this roll of filament costs about $40, and you can make hundreds of prints out of it. Yeah. Okay. Let's do some math. Need to put the computer down. There are lots of really good math manipulatives available to download and print. So if you're trying to teach shapes and counting and numbers, these all fit on a pencil. And they're organized by different shapes and sizes. Looking at maybe an hour to print this one object, but it's something that you can use over and over again. You can sterilize it and clean it and use it for students. Or if you're having a student that's struggling at home, I talked to Mia about this earlier, we can print it off here, put it in a bag, and they can come pick it up in the lunch line, take it home, and it's theirs to work with. Okay. So math is really a good thing to do. Okay, I've given some of you this thing. Tiny little thing, and I'm printing some more up here. Manhattan Island. So I shrank Manhattan down so that it could fit on something like this. And how is this a math assignment? How could this be used for math? We're scale. Yeah, we're trying to get kids to, so I made a scale, I made a ruler out of Manhattan. If you're trying to measure something that's really big, you can use Manhattan now to do it. And let me show you something that's really big to compare it to this. Here's a comet compared to Manhattan. It's a comet. I can zoom in. It's a comet. It's called P67. We sent a probe to P67. It orbited around it, photographed it, and then crashed into it. And P67 is fun to follow on Twitter. It's pretty funny. Okay, now we're going to do some math and history. Okay, so anybody know what that is? Anybody want to guess what that is? It's the actual size. This is the actual size of this object. It looks like a packing peanut. It's about that size. It looks like maybe 2. This is an ankle bone from a sheep. Okay? It's an ankle bone from a sheep. And it's the same bone. If you were to reach down and touch this knob on your ankle, that's the same bone. It's called an astragalus. Astragalus. So we can learn about sheep anatomy. Ours is more rounded because we can move our foot in almost any direction, but sheep can only move their front to back. They're only meant for running forward, not dodging, turning, climbing over rocks and things. It's front to back. And you can see it's almost pulley-like, right? It confines the motion of that ankle, but they also make really good dice. So there's the instructions on how to play this game. So you take these dice and you roll them. And I have a slide I'll show you in just a second of how the kids use this with math. But the ancient Romans, ancient Greeks called these oracle bones, and they also played a game with them. It's very similar to how we use dice. So it's a precursor to how we use dice. Oracle bones. Yeah, sheep. And actually, it's the same bone. They're very dense bones found in the ankle. Or there are also cuneiform bones found in the wrist and things like that. They're all very dense bones. They're good for making dice. Okay, so I'll show you what the results from this in a minute. Let's see, I had one more thing. Oh, yeah, this is one of my favorites. Dentures. Is it there? There it is. These are George Washington's dentures. Yeah, I can't get them under there. Sorry, Lehigh. Yeah, there we go. They're used to it. That's how things work over there. Okay. All right. Yeah, so those are George Washington's teeth. They're actually made of real human teeth, pig bones, and lead.
That's some pretty thick teeth.
Yeah. It turns out he harvested teeth from his own slaves to make his dentures. Yeah. Nice guy. Yeah. So, no, they didn't fall out. They were, this is real. Yeah. Yeah, and this isn't even this is a nice pair of dentures. You should see some of the ugly ones they have in museums. All right, let's go ahead and switch back to the slides. Thanks. And I won't be using the doc cam again. Thanks, Stephanie. Okay. This is a friend of mine. His name is Bernard Means, and he runs a place called the Virtual Curation Laboratory in Virginia. And he scans the daylights out of everything. Most of what he has is history, but this object that he's showing is a brick from Gunnison Mansion, where James Mason's home was. And I have a small version of this brick here. What are those holes in it? What? Not bullets. Fingerprints. So I can actually put my fingers in these holes just like the person who made them back in the 1700s. But guess who built this mansion? Enslaved people. And you can find bricks just like this in Independence Hall. Okay. So, okay, next. When I was doing the museum project, this is a collection. I printed over 45 different artifacts for the kids to use and research. So here's a sample, and here's some of the artifacts. Go ahead, next. This is what some of them look like after they're finished. So you can see the oil lamp, George Washington's teeth, the rusty cup, and then a dog jaw from Jamestown. The dog jaw is kind of fascinating. It has cut marks on it. Things got really bad in Jamestown, so they were eating whatever they could find. Yeah. So, okay, next. All right. I had my students write personal narratives as though they were the people who interacted with these artifacts. This is what one of the students wrote about George Washington's teeth. It says, I can go ahead and read it. He made me do it. Yes, I got some money, but at what cost? I feel less than human. My life is terrible. As a Negro, this is horrendous. George Washington pulled out innocent people's teeth, including my teeth, for his own. What a selfish man. You can see she really started to develop some empathy for this person and the environment they're living in. Okay. Yeah, that's okay. I don't know if you want to read the whole thing. This is another thing I did with 3D printed objects. I built an archaeological site in my classroom. I had real objects and 3D printed objects. The students would collect the 3D printed ones. They had to figure out what they are and interpret what they mean. Okay. Here's the comet again. So the object I'm holding is the 3D printed comet. The picture next to it is the actual comet. You can see they're really close. So when I was working on this online, I found this picture of the comet sitting next to a city, and I said, well, I can do that. Next. So there's that. Yeah, so that's Manhattan compared to this comet. ELA is kind of a difficult thing to teach using 3D printing, but one of the things you can do is author studies. And this is one of my favorite authors. His name is Cory Doctorow, and I always bring this is kind of my lucky charm to workshops. I bring this green head everywhere I go. It's in my classroom. Sorry, but I happened to go to Comic-Con and he was there, so go next. So he signed it for me. Yeah, so he signed the head. Okay. You can do chemistry. I put magnets on the back of these and put them on the whiteboard so you can print off molecules, and you can use cookie sheets and magnets, and the kids can mess around with molecules. This is a project I've done. I printed all the bones from the human hand, and a student can take the bones and arrange them as they think they should be on a piece of clay, and you get some really interesting results.
This is the game that you can play with the astragalus, or those bones that I was talking about. You can see the students graphed the results from the bones on one side and actual dice on the other. And then they compared the two to see how play was different for each. Again, the astragalus is a dense bone found in the ankle, and it makes good dice.
So I want everybody to go to this website. I'll show you what it is in a minute. So if you're online, you can grab the link because I'm going off this slide. All right, the virtual curation laboratory that I mentioned earlier is a great place to find a lot of these things, but it's in a website called Sketchfab. And Sketchfab has high quality 3D resources. The British Museum has shared thousands of objects, so if you're teaching world history, it's a good place to go for that. And museums all around the world share objects into this website. So I really recommend using it, but it's called Sketchfab. And the Virtual Curation Laboratory can be found there. That's where I get a lot of my artifacts for teaching American history. Thingiverse. Thingiverse has an education area. You can see where it says education at the top of the screen. And I've given you all links to these resources in the document. I'll talk about the document a little more in a minute. But some, you can see subjects: art, science, math, engineering, history. There are different filters: K6, K12, university filters, languages. It's not the actual website, so I can't really scroll through it, but I'll show you more in a minute. I advise you to make an account. If you make your own account in Thingiverse, then you can actually build collections of objects that you like to use with students. And the math resources are really amazing. You can see in one of these pictures is a loom. Another one is an Escher project, and then Lego or origami something or other. And then Tinkercad. We haven't talked at all about creating things in three-dimensional space, but Tinkercad allows you to do 3D design. And this is where I sent my students. You can set up your own, you can see a teach section. Everybody see where it says teach? You can set up your own classrooms in Tinkercad and do assignments, and there are tutorials on how to do things. I use Tinkercad quite a bit with students to make 3D objects, and this is where they made their Mesopotamian stylus for the tablet project. Okay. Now, beyond all that, our kids are at home. What can we do? This is called the Mill Girl. If you're teaching Industrial Revolution, this is something you can find, and it's in Sketchfab. I'm going to go ahead and open this and show you what you can do online with these 3D objects. And Sketchfab has buildings and all sorts of things that you can interact with. But here's this model in person. It's already in Sketchfab. Okay. Yep. Yeah, this is not printed. This is fully online. And it's an interactive model. All the models in Sketchfab are also available. So this is the mill where the mill girls worked. This is a statue honoring the mill girls. Somebody scanned this probably with drones, stitched the pictures together, and you can actually go and look inside the windows. And you can see Venetian blinds in there. I found one, there's somebody going around China taking photographs, making models of old streets because China is wiping out its cultural heritage, and they're going around documenting it all with these models. You can't print them. You don't even want to print these. They would fall apart if you tried to print them. But you can interact with them. And you want to go inside? So the windows are kind of frosted over, but you can see the Venetian blinds in there. Yeah. But I was looking at one of the Chinese models, and you could go into stores and look at people ordering food, just like it was captured in a moment of time. It was amazing. But this is something, so you could just send your student the link. And does everybody see this little box down here? It says View in VR down here in the corner. You have VR goggles. This works with VR goggles. So those are those things that the students can put their phones in and interact with these things online. I'm not going to work on it. I'm not going to show it to you here because it doesn't look like much of anything. Let's take a look at another one. The Smithsonian does this also. They provide for VR objects to interact with, and this one is cool. This is the inside of the Apollo 11 command module. It takes a minute to load. They used to have a tour where you could actually explore the whole module. I don't know I haven't found it, but this one's pretty good. So these are the actual seats where the astronauts sat for 4 days on their way to the moon, 3 days on the way to the moon, and 3 days on the way back. So you can explore this. You can let your students explore that. Let's see, back up a few slides. I think it's this one. Let's see. This one. So I wanted to show you what they're looking at in their VR viewer. I put a link in here. They were talking about sites in Mesopotamia, specifically Syria, that have been destroyed by ISIS. And so this is one of those sites. They show you what's left and what is gone. And each of these dots is a number that you can click on and get information about. It's still loading. But they have these in their VR viewers talking about places in Mesopotamia that have been destroyed by war. Oh, and that's in French. I don't know if you can fix that. But you can see how you can interact with this. And it's not something that you 3D print. It's something that is meant to be looked at online. And again, it has the goggles. hundreds of these kind of places on Sketchfab. Okay. Any questions at this point? Okay, I'm not going to that slide yet. All right, I wanted to go over the document I gave you real quick. Let's make it a little bigger. Just to show you what's in it. Oops, come back here. Where are you going? All right. These are the two printers that are owned by Sequoia. The Monoprice Mini Select, that's this little guy. And then the Dremel 3D20 is the one that is at both Lehigh and here. That's the one we got for signing up with the, this is a sweet printer. Does a really nice job. The Monoprice Mini Selects, we have 3 of these. Excuse me, and they're pretty good. The link that I provide is to for the Mini Select is to the software you need to actually work with the models. So if you're going to do any modeling and use the Mini Select, you need to click that link, and it'll open a folder that where you can download the software to run them. If you want to use the Dremel, again, you'll have to go to their website. You want to find the Dremel Lab 3D Slicer. I happen to have that open, so let's go ahead. Let's see. I might have to. Let's see. Here it is. Okay. So the 3D Slicer, this is what you have to put the models into. You upload the models into this, and I'll have tutorials and stuff to help you with that. And then you have to click Save to File once you have the models where you want them, and then you save it to a mini SD card. Okay, back to this. So those are our 2 printers. Free software for you to play with. Educational resources. I checked all these links and they all work just fine. Thingiverse Education. Some articles and blogs that will help. If you're trying to learn more, if you really want to know more about 3D printing, I'll show you a couple articles that are really helpful. Some free or low-cost resources. Terrain 2 STL is really cool. Let's open that one. STL is the file extension for a 3D model, but what this does is it allows you to capture places anywhere in the world and turn them into a 3D model. So if you're doing anything with geography, Terrain 2 STL, you just click Generate Model, and then click Download. Wherever this is, I just made a 3D model of it. Isn't that cool? That is right here where it says 3D Design on your document. It's Terrain 2 STL. The one below that called Image to Lithophane. A lithophane, litho means rock, phane means picture. There used to be an old style of art where people would carve images in alabaster and then you put a light behind it, look 3-dimensional. This allows you to 3D print those same images. You can take any picture, any JPEG, upload it to this website and turn it into a lithophane and then print it. Text to Braille is blocked by Sequoia, so we have to get unblocked, but it allows you to actually write in Braille and then print it off. And then some other resources. Here's a link to Thingiverse, a link to my channel in Thingiverse, STEM Nation. If you want to see how I set it up. Some other articles and things. These 2 articles, one by Frigo, The Power of Things and Object-Based Learning is a really important article if you really want to get into 3D printing. And the one by Dr. Means, Promoting More Interactive Public Archaeology. Both of these really talk about how to interact with, use these things with students. And I gave you a link to both articles. You can download them and read them. And then how to make your own Google Cardboard. So you share this with a student, then their parents or the students can figure it out how to make their own VR goggles out of cardboard. And they can buy the supplies through this list. And then link to the Smithsonian X3D. I also provide links to curriculum that I've written. So Physics of Frogs, these are all integrated curriculum, so they incorporate different elements of STEM and other subjects. So biology, physical science, and engineering. That's how frog legs work, and you can 3D print a fake frog leg and put rubber bands on it and it hops. Math and astronomy, that's about the comet, the thing I showed you about the comet. Here's using the bone dice, the one I showed you the bone dice, and then another one that I didn't talk about called the child's leather shoe. It involves role play, slavery, and Civil War history. Any questions about the resources? Okay, everybody's quiet. I don't know what that means. Yes, we're doing that next. Okay. So this is the last slide. How would you use 3D printing or haptic learning with your students? I've given you a link to a Padlet. Look for resources in Thingiverse or on Sketchfab. Think about how you might use them with students. If you want to go to Cura and design your own thing, you can walk through a tutorial that will let you design your own keychain with your name on it, and we can print those. I will copy this link and put it in. Oh, there's a QR code, so you can scan the QR code if you want to get to the Padlet. Okay. When I started printing for the museum project, for those of you who couldn't hear, Ms. Damiani just asked if I had students do any of the printing. When we started that project, I had a very temperamental printer, and so I did all the printing. But now that we have the mini selects and the Dremel, they're a little easier to use, and I know students, especially the more responsible students, could use them. Don't think they can use a Chromebook. Yeah, but they can save it to. They can download their files to an SD card, and we can put the SD card in these machines, so they can print that way. Tools for robotics, game pieces, create characters from stories. One of the things I thought about, because I'm trying to think about how to use this with ELA, a lot of students have issues structuring sentences, but if they made a tool that would help them remember, by making something, they remember. So it's more important to make something than it is to write something. So if you go to send them to Tinkercad, tell them to make something that reminds them of the parts of speech, or to use punctuation, they're more likely to remember it. Create characters from stories. Math games. Okay, that's it for the workshop. If you want to hang around and share what you've designed on Padlet, you can. I'd love to see what you do. Love to know how you think you might use this. And thanks for joining us online, everybody.